I'm Richard Levy, and I'd like to thank the organizers of TECHFEST for this opportunity to speak to you today about 3D imaging and historic resource management. Now, a lot of you are probably familiar with this technology because some of you have used it on your cell phone. We now have the opportunity to capture 3D images using photogrammetric techniques on even our cell phone. Today, what I'd like to talk briefly about is how we can use 3D imaging, both laser scanning and photogrammetry, to capture images of our 3D world and use them in architectural and archaeological work. Our case studies will be drawn from both of these areas. Now, I would be amiss not to mention that many of the principles that underlie photogrammetry and 3D laser scanning were developed in New Sumerian Ur period 2100 BC. And here you can see a land surveyor producing a plan of a field, and in that diagram you can see many of the principles that later Euclid would incorporate in his work on geometry. Now, the tradition of surveying is ancient. It goes back thousands of years, and in fact, in some ways, it really hasn't changed all that much because we still go out into the field and collect data using instruments based on basic geometric principles. We're probably aware of the use of laser scanning because of a recent fire of Notre Dame Cathedral. And if it weren't for the fact that 3D imaging was used to capture in detail both the interior and exterior of this great work, that restoration would not be possible today. Now, laser scanners come in two forms. One is time of flight, which simply measures the time it takes for light to hit the target and bounce back and be received. That's a very simple technology, but it requires great accuracy. Now, laser scanners can be mounted on all kinds of devices. You can mount them on helicopters and even on drones. Now, the principles of triangulation scanners are ancient, and in fact, it's merely a case of determining where an object is based on the emit of a laser pulse and then measuring it at a distance askance from the laser itself. And can't go into the details of that, but it gives you a very accurate representation of where points are in space. There are many different kinds of laser scanners that fall under this category of triangulation. They're highly accurate, but their range is really quite limited. Today there is a whole range of laser scanners that are out there for commercial work, and some of them are affordable that even an individual might want to acquire them for doing work in related areas, such as industrial design, architecture, in addition to archaeology and urban planning. Now, the first case study I want to look at involved the laser scanning of a church in Alberta, Canada, almost 20 years ago. And it will give us some sense of where the technology has been and where it's going. Our goal was to use it as a design tool and also as a presentation tool. Now, in working with point cloud data, we have to remember that's just a starting point. And this is the workflow for how we would use that data. Starting with point cloud data, we would then perhaps develop a mesh model, and then we would translate that data into other formats that we could use for other purposes. In this case, we needed to create data for the architects, and we also wanted to create data that could be used in building our virtual model of the church, interior and exterior. Now, the purpose of collecting this point cloud data was to have a comprehensive model that the architects could use for their renovation project of the interior space. Here you can see that point cloud data represented, and here you can see the mesh model that was created from that point cloud data. We use that mesh model to create a virtual model of the interior space. Here is our exterior view, and here you can see how the data was collected for the exterior. We situated our laser scanner on the roof of buildings in the area. This is our final model of the exterior. Now, the architects needed at the time sections through the space. So what we did was took that data that we captured and created literally thousands of sections through the church. And here you can just see some of those sections. There's so many of them, it looks like just a solid model. Now, by registering these two sets of data, the exterior and the interior, you could begin to explore all kinds of architectural issues, such as how thick are the walls? What about window details? So that if you needed to change out the windows, you would have an accurate model on which to base those design decisions. Ultimately, the architect took our data and developed a renovation plan for the interior space, which included all new balconies and new seating. And then we took that model and placed that inside our virtual model of the church. By placing this in a virtual world, we could then simulate what the sight lines are going to look like before the church is built. In other words, we can design it, test it, and then we know that it's going to work. Now, what this case study demonstrates is that even 20 years ago, the price of technology was falling, and it enabled us to create a base model from which the architects could work. And there was a great deal of value to the client in being able to test all those sight lines of the architect's proposed design long before it was constructed. The next case study I'd like to look at involves my good friend and collaborator, Peter Dawson, in the Department of Archaeology at the University of Calgary. And we began this project, again, almost 20 years ago, and the goal was to reconstruct a traditional Arctic house in the far north of Canada. Now here you can see the archaeological remains of that house, which is made out of whale bones. And let's just take a look at that from above. And Peter had developed a 2D drawing of that site, but you were not allowed to remove any of the artifacts from the site. And so our goal was to do a reconstruction of this house in virtual space. So how would we do that? Well, we came up with the idea that if we could scan a whale skeleton, then we could use those components as our building blocks for actually doing the reconstruction. So we found a whale skeleton of the type that was used for building these Inuit houses in Boston at the aquarium. And from that, we created our laser scan. And here you can see about 3 million points that was used to create our model. And from that, we created a mesh model of that whale skeleton. And here you can see it in 3D. And from that, we extracted the necessary components that were critical in our reconstruction. So again, the flow of data is very important to understand. So we started with our point cloud data and then translated that into a mesh model, which then could be used for not only reconstructing this 3D model, but also for testing it in an environment where we want to consider lighting issues or structural issues. So this is one of our explorations. And in fact, by having the ability to develop 3D models in virtual space, we could test out a number of different possibilities. And the exciting thing about this research is that we were able to use this model in structural analysis tools so that we could actually discover whether or not our proposals actually could have withstood not only the weight of the structure, but also the wind loads that would have been severe in the far north. We also used our model for lighting studies to understand more about how these environments would have been not only perceived by their inhabitants, but what happens when you're working inside these spaces. We were also able to bring our model into a virtual reality cave and let students explore this environment in 3D. Now, the last of the projects I want to turn to using laser scanning was our Fort Conger interactive virtual world for exploring the science of the 19th century. Now, if you go to the website, you'll find that it's organized by expedition. You'll find a timeline. In this view, you can see the 1881 view. Now, later, Robert Peary would come to this location, and what he did was he took down the building that had been built there before and used the materials to construct the cabins which still remain on the site. So to begin this process, we started with the reconstruction of the Peary huts. We used a number of different scanners, and But I just want to point out that in the process of being there for almost a week, 1.6 billion points were collected over the entire site. And that data was then used to create not only mesh models, but also formed the basis of virtual worlds that were then used in our website. Here you can just see part of one of these models, and there you can see the Peary huts. The scanner also allowed us to capture data of the objects that still remain on the site. And that data was then used to help us reconstruct the objects you'll see in the virtual world, including this coal stove. We also had a high-resolution Minolta Vivid 910, a triangulation scanner, which allowed us to capture data on objects that were found there at a very high resolution. Now, one of the goals of our project was to reconstruct the main building where the Greeley expedition was in 1881. And here you can see in an air photo the outlines of the foundation. Now, we were able to scan this area, and from that we had accurate information about the location of all the objects that you would find on the site. Using that information combined with photographs and drawings of the site, we can then reconstruct the expedition house. We could determine where the best location was of that main building, and using photographs and the information we knew about the materials that they brought with them, we could reconstruct the actual structure. And here you can see part of that reconstruction structure. And here you can see in its final delineation how it actually looked. We also used the laser scanning data to help us with individual objects that we saw in photographs, such as these doors. We put it all together to create a virtual world which you could explore on the website. And here you can see Greeley's corner. Lieutenant Greeley was in charge of this expedition, and this is our computer reconstruction of that space. And here you can see the sleeping and eating area, and here you can see the computer model of Lieutenant Lockwood's corner. Now, I also wanted to show you a 3D animation of the space to give you a sense of how it might have felt to be there. And as the camera passes around, you're going to see the view of the pendulum, which was part of the scientific expedition. And there we have Lieutenant Greeley's space off in the distance there. If you look at our website, what you'll find is that the various scientific laboratories that were used for investigations are there for you to actually explore using our virtual world. And here, if you go to our website, you can actually learn how this pendulum was used to determine what the gravitational constant was at this location. And if you go to our website, you can learn more about how it actually works, some of the science behind it, and actually you can explore yourself how it would be to actually count the number of times over a period of, let's say, minutes, this pendulum would swing back and forth and make that calculation of the gravitational constant. I ask everyone who's interested in this area to visit our website, and there you'll find Fort Conger publication database, as well as some very interesting games that you can play that will teach you about the science from this period. Now, the last thing I would like to do in the time remaining is talk very briefly about photogrammetry. Photogrammetry got its foothold in the 1850s when various scientists started to develop camera technology so that you could actually use photographs to determine points in space. But the question I have to ask you is, if you're going to use photogrammetry, what's going to be some of the issues? And certainly, the quality of the photograph matters. So the image resolution as well as shadows, because there's no data in the shadows. And just to give you an idea of how this technology can work for you is an example where I'm creating a model of this relief using just 6 images from an ordinary CyberShot camera. Bring it into an application like PhotoScan, which I would ask you to take a look at. And from these views, I can organize the data and create a 3D image. And just to prove to you that it is 3D, here you can see the output from that model rendered in 3D. So I just want to point out that the technology of 3D imaging, whether it's laser scanning or photogrammetry, has many applications in architecture and archaeology. And although I only had a short period of time, I think you can begin to imagine how you could use it in your own research. And if you're interested in looking at these projects that I've presented today in greater detail, here is a list of publications. And I just want to thank everybody at the conference for this opportunity to speak to you today.